Hello. So this is going to be a sort of quick tutorial to explain some gotchas regarding blueprints that aren't really explained in the documentation, but it's something that you kind of come across when you're just developing something in Unreal Engine using blueprints. And it's not a limitation, it's more of just a part of how the tool works where you just need to be aware of it so you can account for it in the future to make sure your code is efficient and working and, not struggling and having problems with it. So, yeah, let's get started. So I have this cone here, and to explain it, we're pretty much just going to be using like a thing where it spits out two random numbers, and then after that, I'm going to be going over some other parts of Blueprint, another part of Blueprint really that is a little bit finicky. So, in my opinion, but all right. So if I hit play, it spits out 92 and 92. All right, those are the same number, obviously. So I open up my example, and what I'm going to go over is the difference between functions that are constant, pure, and pure plus constant, where you click on constant and pure for the function, and what the differences are between them all. So just to let everyone know, in general coding, standards, when you mark a function as constant, basically that means you're not changing any variables or states or anything like that. You input a value into it and it spits out another value, and it doesn't change anything. It doesn't change like your health variable. It doesn't change anything. All right. It's just meant to be like a box that you give information and then it spits it out, like a calculator or whatever. So what I have here are, I'm going to put these breakpoints back on. So it runs the print string twice, and pretty much what it's doing, actually it'd probably be easier if I separate these out to make it easier to understand what's happening. So, oops, plug that in there, and watch this value, plug you there. Alright, so I'm going to go into the const function, and all three of them really, what they do is they just get a random integer between 0 and 100, and then they just return that value. Okay? And the difference between pure and const is that pure is also agreeing to not change any values outside of this object or anything like that. It's not trying to change any values. It's meant to be an agreement between the programmer and the code, and just like other programmers, that this value should not be changing anything, or this function should not be changing anything, the same way const is. But in Blueprint, there's impure and pure functions, and basically, the short-term answer is it removes the execution pin, so you don't need it, sort of thing. But there is another side effect of this. It will also run the function twice, or it'll run it over and over. Versus const, as long as you don't run through the execution pin again, it's not going to run again, so you can get the same return value and just reuse that. It's sort of an optimization and sort of like just how the tool works. So, and pure const will be acting the same as pure, except you can't change any state. Pure, for some reason, allows you to be able to change state. Really, it should just be marked as pure plus const and not have them separate, but I completely understand where they're coming from with this, where what if you just need to, have stuff running, in Blueprint. In C++, that's typically not the case as well, where in C++ you wouldn't be changing any state inside of a pure function. Okay, so let's run the example. So if I hit play, all right, it goes into the function for get random integer, constant version, and it gets a random integer in range of 0 to 100 and returns that, and I hit resume, prints the string of 18, and then we're going to go down to this one, and it uses 18 again, because this is the value it currently has for its return value. We haven't run this function again, so it's just going to reuse that same value that we already have. All right, so if I hit stop, so now I'm going to drag this, connect it to the pure version, pure only version, that is. All right, I hit play. It runs the function for the pure version only. Whoops. Oh, well, const, because it's in the execution path, so it's going to run, but we're not using it, so just skip that. Let me rerun this over. Hit play. Did I? Oh, yeah, sorry. Make sure these are all having their breakpoints on. Save, hit play. Alright, so now get random integer pure. What it's doing here is it's getting a random integer in range of 0 through 100. It's changing our variable health that is on the example class itself, you know, just as an example to make it easier to understand, you know, without using other names and stuff. It's just health. It doesn't do anything other than just be changed. And then we're returning what we got, which is 94. I hit resume. That's our value is 94. Okay, then we're going to go to the print string. I hit resume. It runs the function again. So now the new value is going to be 49. So I hit resume. Now it's 49. So we have two different values that have happened, where it's 94 and 49. I don't know why they're flipped. It's straight up just supposed to be a random integer, so I don't understand why it's, you know, just flipping them. It might have just been completely happenstance or whatever. So, and then I hit stop. I'm going to remove this breakpoint so that way we don't have to deal with that. And I drag this over into here. And we're going to show the pure and const version. So pure and const, I cannot change any state. So if I connect this into here and hit compile, it gives me an error. Health is read-only within this context and cannot be set to a new value. So read-only means I cannot be changing anything. I can't set it. So I'm going to connect this back. So that way we're not changing anything. I can probably just delete the node and just plug this back over here. And it basically kind of repeats what the pure function was doing, except without changing any state, which is important. And sometimes you just want functions to not change state, and it's sort of like a compiler optimization as well. So, go back to the event graph. I hit play. We get our random integer in 0 through 1 in the pure and const range. I hit resume. Our value is 96 on the print string. I hit resume again. It runs the function again. I hit resume, and our print string is spitting out 24 now over here. So yeah, that's regarding pure and const just in general. There's a few other different edge cases between them. Sorry, I keep burping. And I moved them over here just so you guys didn't have to focus on it. So I'm going to remove these breakpoints just so there's less distraction. So another thing to know is with select nodes, the and or nodes, or any pure functions that you make of your own, like example pure select that I made here, it's going to run through each of the input parameter pins. So if I'm checking an actor is valid, and then I'm going to also check if it has a tag, you would expect it. So if it's valid, well, actually, let me check it over here. This is a better example. So if it's valid, and then we would also theoretically check if it has a tag, right? Wrong. What it's actually going to do is it's going to say, is it valid? Yes, no. If it's not valid, all right, next pin. Even if it's not valid, we're still going to try and run actor has tag, which is going to give you a blueprint error. So to fix that, if you're doing valid checks, make sure you do those first in blueprint before you actually do stuff regarding those values. You know, after they've been valid checked and everything like that. Or check to see is valid. You can do a bunch of them like is valid, is valid, is valid. Just make sure you're doing like checking stuff inside of it after you've checked if it's valid, sort of thing. And the select node is the same sort of thing where it will run the false parameter even if whatever this is spitting out true. What it's going to do is it's going to run false, then true, and it runs them every time when you go through a select node. Even if you have multiple input parameters or whatever, if you have an enum or whatever, it's going to run through all of them. And the reason why is the way that blueprint pure functions work, where it has to run through each input parameter at least once. So it works with the OR node, NANDs, like anything where it's a pure, well really, it's just going to run it with just about any function really in blueprint because of the way it works. Where it just has to evaluate this stuff, and then in C++ is where it picks like which one to use, using a compiler-esque method in the virtual machine. Sorry, compiler-esque isn't a technical term, but you know, it's just the magic behind the scenes kind of thing. that the virtual machine is handling this stuff. So really what it's doing is it's creating a new function in here inside of C++ behind the scenes when you're using the select nodes, and it's using this to check, or it's using index really to check which parameter to use, but that has to be inputted into its function. So what it's doing in C++ is it's essentially doing like going in here and going select, and it's going, okay, this pin here, this is the parameter, this is the thing we're using, this is the thing we're using, and return that kind of thing. So, sorry, that was kind of a weird way to explain it, but basically it has to evaluate false and true. Even if you're only using true, or if you're using only false, like it's that sort of thing where it's better to use a branch because you know the execution pins will only run that code. So just a little catch-all thing. And then I'm going to show you with this example. So because it has to run through these, it has to run through both of these at least once. Compile, save. Basically, we're just reusing the pure int and pure int const or whatever, and it's a little bit finicky with the way it does it. So this is my special function that I made where it's an example pure. It's really just a pure function that inputs A and B and just doesn't do anything with the return value. Okay, so it's going to call this function, and what's going to happen, oops, let me remove that. Did I remove this? Yeah. Okay. So, and this one, yeah. All right, so we've hit our branch. You are seeing that it's going to run 15 and 94. And we're going to get true and true because they're above, they're 1. You're greater than 0 kind of thing. If it was 0, it would return false. So if I hit stop. So I'm going to plug this one into here. You would expect the pure function to run again, right? Incorrect. It only runs once, so it's going to be 95 and 95 again. So those are the weird little gotchas that you kind of have to look out for, and just kind of, if you're expecting this to run twice or something like that, just like test it really quick, you know. Like this would probably run twice, I'm assuming. Let me check. Watch this value. So 27 and 100. So yeah, it's going to run it separately because they're not connected to each other. So it's those kind of weird gotchas that you have to look out for. And I just wanted to bring these up because a friend of mine was running into an issue where he had a bunch of valid checks, and then he was also checking like this, and basically like he was having errors and yet everything was valid, and it was just causing problems. And I let him know like about this weird issue with it, and it would solve this problem. You know, it's that sort of thing where you just have to know about it and you can look out for it in the future. So I hope this was helpful. Let me know if it was. Yeah, have a great rest of your day. Bye.